Hello everyone and welcome to Sewer University. We're going to talk today about the history of sewers and clean water in Northeast Ohio, specifically the greater Cleveland area. I am Frank Greenland. I'm the Director of Watershed Programs. This presentation is available on our website at NEORSD.org/SewerU. We've spent a lot of time talking about how sewer systems evolved across the greater Cleveland area. Now I want to shift to what I call Wastewater Treatment Plant 101. We've collected sewage. Now we're bringing that sewage to a treatment plant, and our job is to clean that sewage up to make it safe for the aquatic community and safe for you and I in terms of recreation. So we're going to do a little talking about what treatment plants do and what that process is. And again, the treatment plants were constructed in the 20s and 30s across Northeast Ohio. And in those days, the regulations were nowhere near as stringent as they are today. And these systems have evolved, and we're in another phase of advancement at these treatment plants to make them a little more sophisticated. But the process is very simple, actually. When you bring sewage into a treatment plant, remember, we're bringing them in big-time interceptors, very large tunnels, very large pipes, some of them in excess of 10 feet on the sewer side, and the tunnels are 24 feet in diameter in some locations. There's a lot of junk can get into a sewer system. So preliminary treatment is the process at the front end of the plant to make sure the heavy-duty stuff, and I'm talking rocks and trees and litter, that large-scale litter, believe it or not, can get into the system. It can wash off the street and get in. Sometimes people dump things into sewers, mattresses, whatever. So we've got to make sure that that heavy-duty material does not get through the treatment plant. That's what preliminary treatment is, and we'll show you a graphic. Primary treatment is the next step. And essentially, primary treatment is swimming pools that slow the water down and allow the solids that are in the flow stream to settle. Those that will settle pretty quickly settle out in primary treatment. Secondary treatment is a process where we use bugs, microorganisms. And microorganisms like to chew on organic pollutants, and they do that for food. So their job is to remove the gross contamination by feeding on organic pollution, and they too settle out in swimming pools. And at the back end of the plant, we want to make sure that the bacteria levels are low enough to support recreational activities. So disinfection, we use a bleach type compound to make sure we kill off the E. coli before it gets to the receiving stream. So again, the three treatment plants. The one to the left, westerly, is a slightly different process. It's called trickling filters, and I'll show you a little graphic of that. The other two, southerly and easterly, use what we call activated sludge, and it's a mixture of bugs and wastewater with a lot of oxygen. Again, these plants treat a lot. Most of this flow is wet weather flow. You get a lot of spikes of wet weather, but southerly is up towards 40 to 45 billion gallons a year. That's a lot of flow that gets treated in these treatment plants. But these treatment plants are award-winning treatment plants. Rarely is there a permit violation. Sometimes for years, nothing. And we are regulated with a number of chemical constituents that we have to meet. So these plants are extremely good at doing what they do. These are the processes at a treatment plant. I'll show you slides on each. Preliminary treatment, primary, secondary disinfection. I also threw in solids handling. And that's a big, expensive process. And when any of these steps generate solids, they drop to the bottom, or the heavy stuff gets scraped off a screen. So you have to process not just liquid, you have to process solids. And we'll show how that happens. This graphic is extremely busy. All I want to show is the grayish, the light blue or grayish flow streams. That's what we call the wet stream at a treatment plant. So the wastewater is flowing through different tanks, preliminary treatment, primary, secondary, disinfection, and out. All the orange and red is the solids flow stream. Each tank, stuff settles to the bottom, and you have to remove those solids and eventually deal with them. Truck them off to a landfill, incinerate like we do. So the solids flow stream is a very complicated process at a treatment plant, but it's just as important as the wet stream. This is preliminary treatment. This is a bar rack. This is a scraping mechanism. And so what's happening here is wastewater is flowing through a bar rack. And the bars, I don't know what the spacing is today. Let's say it's an inch apart. Wastewater's flowing. There's vertical bars. And those bars are there to, if there's a tree coming down the pipe, they get it here. Because anything big that could get past this point will plug pumps, mess with equipment, damage equipment. So we've got to take care of it right in the front end. So that's a big, so the rags and junk we collect at the head of the plant are removed in preliminary treatment. These are mechanically clean. Back in the day, they were not mechanically clean. They were cleaned with individuals with rakes, and this stuff smells. This is bad stuff. So not a fun job, but we mechanically clean. The skimmings go into hoppers and they're disposed of at a landfill. The other part in preliminary treatment is what we call grit. We need to deal with grit. So grit, in its simplest form, is coffee grinds. Coffee grinds are pretty gritty, right? And they sail through the wet stream and settle out. Since they're so gritty, or street runoff, all the little rocks and pebbles in a street, or eggshells, or anything like that, that can be sharp and abrasive, we need to get rid of them in preliminary treatment through what we call aerated grit channels here, and allow that grit to settle out. If we don't, because they're so gritty, they'll start to erode pipes, and they'll tear up pumps, and they'll degrade metal. And over time, your pipes will burst, or your pumps will wear away. So we don't want that. So we use what's called aerated grit. This is an aerated grit channel, where we put some air in, allow the flow stream to tumble. You want to clean up that grit. You want to make sure you get rid of stuff. We allow the grit to settle and we remove it. So that's what grit looks like. Now, to me, that looks like coffee grounds. But it's a lot of that and a lot more. We've got to get rid of this in preliminary treatment. This is primary treatment. Now, primary treatment at wastewater treatment plants, the tank configurations are all different. These are large rectangular tanks, and what we're doing here is slowing the flow down. This is sewage coming from your home, or stormwater in a combined sewer area. We're slowing the flow down in these tanks and allowing the solids that will readily settle to the bottom to do so. So we need hours and hours of what we call detention time through these tanks to make sure the velocity is very slow, solids go to the bottom, the cleaner water pours over the top, and you can see the treated primary tank water flowing over the top weirs. Secondary treatment is a couple-step process, and I said microorganisms are used to chew on organic compounds and other pollutants. So there's a whole host of different types of microorganisms in the flow stream. They like the polluted wastewater. They like that as food. And what they'll do is eat that food, which reduces pollutant levels. They'll reproduce, which creates more bugs. Some of the bugs die. They have to settle. So it's a balancing act of bugs and treated and wastewater to make sure the right combination is there so that you reduce the pollutant levels but don't create too many solids. Secondary treatment in an activated sludge where you're mixing bugs, wastewater, and oxygen, needs a lot of oxygen. So heavy-duty blowers at the plant to make sure we're supplying enough oxygen to keep a healthy bug community. And then we use the same types of clarifiers. Now these are southerly, and these are circular clarifiers. Same thing, we're slowing the water down to allow pollutants that will settle, dead bugs that will settle, get all the solids out. And really we're at a stage here where the water has essentially been treated. So we've gotten the solids down to whatever the EPA levels are, chemical constituents, metals, organic compounds, everything. So that's secondary treatment. The very end of the process, though, in the recreation season, we need to disinfect. So what these tanks are disinfection tanks. Chlorine's applied at the front where the water's coming in, and it's bleach, sodium hypochlorite. And the bleach, with mixing and time, kills off microorganisms, and E. coli is the indicator organism. And we have a level of E. coli that we've got to be under to protect recreation uses of the water body. And so it's a combination of bleach, and then at the tail end, another chemical is used to make sure that any excess chlorine that still exists, because chlorine is a very toxic compound to aquatic organisms, is removed. And we do a great job at this as well. Each plant has it.
The grit, floatable, sludge, what do you do with them? Do you have contractors come in?
Okay, good
What
question.
is done with the extra?
Grit and floatable materials, the skimmings and grit at the head end are trucked away, and they go to an approved landfill. The other solids, the stuff that sits at the bottom of the primary tank and the bottom of the secondary tank, and you'll see a slide, we incinerate, we collect. We have a process to continually get rid of as much water in those solids, because water is expensive. If you're going to truck it, you're going to pay for a lot of water. You want to pay for a lot of solids. So we got to get rid of the water. Now, we use incineration, so you don't want to insert solids in an incinerator that's wet. So we have a process of getting the water out of those solids, and then we feed the solids to the incinerators, where we burn them up, basically. Now, there's ash that's created. That has to be removed and go somewhere. And for a while, we've been storing with some available land at Southerly, and eventually I think we're going to have to truck that off as well. But you've taken a massive volume of solids and through incineration, made it a very small quantity. Now, incineration has some air pollution implications, and our new incinerator has got state-of-the-art, scrubbers and what have you, to make sure we're not creating an air pollution problem as well. So we talked about solids handling. So these are things that are drawing solids off the bottom of these tanks. We've got to get the water out. We use incineration. So once we get enough water out of the solids, they're constantly fed or intermittently fed to our multiple hearth incinerators. And these are very high temperature, and they use those solids as fuel. And if you can get the right balance, what they call autogenous, they'll self-burn. And you can shut the gas off and they keep burning. This is our new renewable energy facility at Southerly. It's a $150 million facility, I believe. But that's how the district has chosen to manage solids. And in fact, through a force main, we pump solids from our easterly plant to Southerly to be incinerated. Westerly has its own setup and its own incineration complex. So this is what we've chosen. There are other options. You can land apply if the solids pollutant concentration is low. You could landfill, but landfilling is expensive, and landfill space is diminishing. So we've chosen incineration. That's Sewer University.